Okay. Thank you. So yes, I'm Jean-Paul, and I work at Target Holding. There I have the title of senior machine learning engineer, but I also do a lot of stuff on building backends, building front ends, websites, stuff like that, because that's all part of our proposition, and I will come to that in a bit. But the core of Target Holding is actually getting value from, let's say, big data. Big data will come back later, but our main goal is actually to do that using artificial intelligence or machine learning. We are currently working on a couple of different areas. So one of these areas is media and publishing, and so that's why I was also interested in the facts and fakes discussion earlier. We do stuff in media. For example, we do online content moderation for a large newspaper. They have online presence, of course, and they have then like a comment section on their website, and you can post comments there. And obviously, you don't want to have any racist comments or other discussions that you don't want to foster in that area. So we build a tool that can help you with that, help the editors with that. We've also built a reviewer recommendation, which is, as you all know, peer-reviewed papers are the core of science, and these editors, they have a lot of difficulty finding the right reviewers. And currently there, for a large publisher, a large team is now working for each article 90 minutes of finding a number of peer reviewers, and that is quite a job. And we've built a tool that can help the editors with that by finding a reviewer in seconds. This is very interesting topic because there are a lot of people called Wang in the world. So and Lee and so on. So you want to distinguish them all, and that is not really a trivial problem to solve. We also do music hits discovery. So I always say that we're trying to find the next Gangnam Style. We do this based on what is being published on the web. So for example, on YouTube or Spotify or these kinds of platforms that you can find music on. We are looking at patterns in the information there. Smart factories is an area that we're working in. We're working on decoding board computers for cars, for example. So cars have a computer that display or they store and send diagnostic information, but it is all encoded in binary. And the company that we work with, they have these small attachments that can use this information to find out, for example, if everybody on the road is suddenly turning on their mist lamps, then there's probably something happening in the neighborhood in terms of mist, and then we can have an early warning system, for example. This is interesting because we have to find out the information in binary streams of data. And in smart factories, we also do predictive maintenance. So predictive maintenance is when we put sensors in the machines and we look at log files from machines, and we try to find out whether a certain machine or a certain part needs to have maintenance or needs to be replaced. Life and health is also an interesting area. We do, for example, energy usage predictions in homes. So this is interesting for big energy companies as well, because they want to have balancing on the net. The recent increase in solar panels are very interesting and very good, but it also creates a stress on the system if it's a suddenly very bright day. So this is going to be an issue, and these large companies are looking for solutions in that area. Health monitoring is also something that we do. So, for example, as a Christmas present, everybody got a Fitbit at Target, and we're monitoring, for example, how much steps you take, and you can find buddies to do exercises with and stuff like that, which is also based on all these sensor information. Finally, in this area, we also do skin infection detection. There are people who have heart pumps, and these heart pumps need a battery. But the line to the heart pump can has to go through the stomach, through the belly, and then that part is a wound, and that can get infected. And we let people take pictures, and we try to detect whether that piece of skin is actually infected or not. And that can deteriorate rapidly, so you want to have an early warning system for that as well. The final area that I want to mention is HR and recruitment. Very interesting for large HR companies or large recruitment companies is job matching. So they have large stacks of resumes and a large stack of vacancies, and you want to find, for example, for a single vacancy, you want to find the best candidate, or vice versa. If you have a lot of vacancies and you want to find the best job for a candidate, then you can find that using job matching. This is all large unstructured data, and it does not work with, for example, keyword search, and that is something that you want to prevent, because if somebody calls himself or herself a programmer and you are looking for a software engineer, will you find him or her? That's the interesting problem here. And finally, skill gap analysis. If you have like these companies that do consulting or whatever, you want to find, for example, find out whether all the applications that you get for work, if your people are still well equipped for that in terms of their skills and so on. And you want to be able to find a gap between the work that you want to do and the skills that your employees have. So that is what we do. Let's talk a little bit about how we do it then. So this is the default model that we usually take. And this is actually the part that happens after you define the question or the problem that your customers have. And for us, we are usually looking in the core process of a company to find out how to help them the best to be the best at what they do. And so these steps are collect data after you've defined the problem, to collect the data, to enrich the data, and to visualize the data. So first of all is collect the data. And usually we start with trying to find the domain-specific data that our clients have. This can be a data set that they own themselves or have collected themselves or already use, and that could be the starting point. But sometimes that's not enough, and sometimes you need to have also data from the internet, for example, from the Internet of People, like social media and stuff like that, or you need to go to the Internet of Things and collect streaming data from sensors. So after you get data, and the data is actually very important, of course, because that's the lifeblood of the enrichment process. The enrichment process then is like all the machine learning stuff, the pattern recognition, classification, forecasting, or segmentation, and this is actually the core of what we do all day. We try to get value from that data and to help them solve that core problem that they have. However, our CEO sometimes says, okay, all some people want is like a single digit, because they want to know whether to evacuate the building or the municipality or something. But you have to have some sort of feedback loop, and so to visualize your findings based on the machine learning is very important and very crucial, because then you can build in a feedback loop. And that is also part of our big picture, because after the visualization you go back to the data and back to the enrichment process and so on. You create a loop. The visualization process and the feedback loop is something that we try to build in all of our products, and that is why I said, okay, I do the front end stuff as well, because I think that is very important. So I said that we sometimes also do big data, and sometimes you get the question, what is big data? And you've probably all heard these last few days about very massive data sets. That could be big data, but big data is not necessarily something that you can define the threshold for. So if you have this little piece of code that says if you have any data set, and if it's bigger than that threshold, then it might be big data. But yeah, it might also be big data because it does not fit in your Excel sheets, or it does not fit on a laptop anymore to process as you want, or maybe you cannot process it on a single commodity server. And this goes way beyond actually the size of the data. This goes also for velocity of the data, or how unstructured the data is and stuff like that. So the big data machinery that we have in place, and that you might want to use if you have any sort of data problem. So I usually show this picture because that actually shows what every component is used for. I don't know if I can show here. Yeah. So the infrastructure is like actually the hardware, the base level that everything is built upon. You can also think about virtualization in terms of infrastructure, because we use a lot of virtual machines as well. The operating system could be here. Then on top of that you have resource management, and resource management can be just the OS, or some agreements that you have with your colleagues or whatever, but it can also be containers or hard enforced limits. Data flow can be very important if you have like very big streaming data problems. We call them also sometimes distributed logs and stuff like that is in that area. Storage is important, of course. If you want to store all that data and you want to do something with it, you can store it, for example, in a NoSQL database or in a distributed file system. Compute is something that you might want to have as well, because if you want to do anything with analysis, you do want to do analysis on your data, then you need to have, sometimes you have to use MapReduce or distributed streaming processes and stuff like that. And it all comes down to the top part, which is analytics, and this is where for us the magic happens, which is the machine learning, and yeah, you can also think about deep learning here and other kinds of analysis, analytics that goes on here. For us, security is also very important, and privacy as well, so that's why I mentioned it earlier. As Target, we are ISO 27001 certified, which means we have processes in place that limit, for example, the access to certain data, and we always classify the data in certain classes to find out whether anyone can have access to it. Is it open data? Then it's probably okay to have it on your laptop, but if it's really privacy sensitive data, you don't want to store it on the laptops of your coworkers. So you have to be mindful of stuff like that, and also this goes pretty far, because it also has to do with, for example, who can enter the office just on a whim, or who can sit into meetings or whatever. And privacy, which is this little picture is about. So, do you store privacy-sensitive data or stuff like that? And you have to think about that as well. A lot of what we do is based around the distinction of structured versus unstructured data, and this is a small demonstration of the difference between the two. So on the one hand, you have structured data for which you have like a name, which is in a clearly defined field, date of birth, the sex, or the address. And on the other hand, you have unstructured data, and the unstructured data is just text or just images or what have you. And what we do when we have unstructured data, for example, in the job matching problem, we have a lot of unstructured data, just a lot of vacancies and just a lot of resumes, and we want to find a match between those two. And on the structured side, we also do things like, for example, if you have missing data, you have columns missing, or you want to find out whether two entries in a database are actually the same because you missed data or because it's corrupted data or stuff like that. There's something that we can do also with structured data. And this is always the distinction, and yeah, so that's very interesting. So you probably have heard about machine learning in this conference as well. So I always make the distinction between the traditional way of programming and the machine learning way of programming. And the traditional way is, okay, you define your question, you build a program by putting out like if this then that programs, and then yes, you get your problem solved hopefully. On the other hand, machine learning does a little bit different. We start with the question as well, and then you put your data through something, but together with the output, because the output is the thing that you want to predict. And by building a feedback loop, you can have that improve by itself because of the machine learning algorithms that are present here. So we don't build the actual program anymore that defines the rules for deciding what should be the output. So in terms of the presence and the feedback loops and the UI, we also build apps. So sometimes a customer comes to us and they have a very good idea about how to do something with AI and machine learning, but they don't have the data yet. Or if they have the data and they want to have the feedback loop, they also need an app. And this is one of the platforms that we built for Ben Woldering, which is based around storing your contracts. And for example, if you have an energy contract with an energy supplier, then you can get a notification that your contract is about to expire. From the app, you can then find a better deal for the next year. So this is an app. We also build like web tools. This is a web demo of something that could run in a factory. This is actually a cake factory, so we always get hungry when we look at this. This is something, all these machines, they produce logs, right? So you want to find out quickly whether something is wrong, but nobody is looking at the logs. The logs in this screen are flashing by rapidly, and because of all these machines, they produce logs. However, if one of those logs start to change in frequency, that might say something about that there's something anomalous going on. So then you want to have a quick reminder of, okay, wait a minute, this frequency is 90% higher than average. Or if the log line is saying something differently than you expect, then you can also get like a warning because you notice that something is wrong. So this is something that we built for factories as well. Finally, this is a demonstration of a tool that we built for finding out what's the best way to ship certain products. In this case, I think it was oranges. And you can find out, for example, the best way in terms of the amount of CO produced, or how you could optimize for speed or optimize for cost. And that is something that we build as well as a web tool, and you can find the map and you can click around on it. So what is our vision about Amazon Web Services, Microsoft Azure, Google Cloud Platform, or all the cloud platforms for computing and storing your data? Our vision is to not use cloud services because they're usually very costly, especially if you want to have specialized hardware. Security and privacy concerns are very important there because these are all American companies, and then you have to store your data in a company that you don't know exactly what is happening with that. So, and data storage can be also a problem. If you have your data in the Netherlands and you want to ship that to somewhere entirely, that could be a problem if you have large data sets. So our solution is to use our own hardware. We have a couple of machines with a lot of RAM, 3 terabytes of RAM for a single machine, 96 cores, and these machines are used for very memory-hungry processes. This is something that you could not get very easily on a cloud platform such as Amazon Web Services or something like that. But yeah, as most of these cloud platforms, we also use many small VMs across many physical machines to spread load and increase reliability and stuff like that, to run our service APIs and websites, or to also distribute our computing. So all this to show that we're not really building the next Microsoft Azure, where you can click and drag all these different, or maybe a whole others. We don't build APIs or SDKs that you can drag and drop and click together, because we believe that for the things that our customers want, you have to think hard about the problem, and you have to get the exactly right solution for that. And yeah, with that, I want to close off. This is the team as I think half a year ago, so I think we've doubled now almost in size. So we cannot fit all anymore on this little platform, so we have actual desks now. Yeah, we also have vacancies as ever. So if you're actually a machine learning engineer, or you are interested in building apps or interested in scalable technologies such as databases or whatever, please come and find us or my two colleagues over here. And yeah, let's have a cup of coffee or something. That's it.
Okay, thank you very much, Sajjad. Questions?